Hello everyone. So let's talk about vertical circular motion or motion in a vertical circle. So you know that like the easiest example is like you're taking a string, okay, or a rope or something. Then at one end you are connecting a mass. Then you're making a circle like this. Okay, you are just rotating like this. So you know that like the body will be moving in a circle and it will be a vertical circle, right? And this is, of course, it is an example for non-uniform circular motion where acceleration is acting on the body. So let's talk about this circular motion in detail. First, I'll be giving the general idea of it, and then we will be moving to each parameter. So velocity, tension, difference in velocity, and the types of motion and the conditions, everything we would be discussing in this series. So you can just follow this one. Okay, most of the problems I would try to finish after like in each videos. Okay, that's it. So let's talk about first the motion in a vertical circle. So as you can see that like the first thing you can see a string is here and this OA is the string and a mass is connected to it, mass of M, and this is moving actually in this direction. And at this point, as you can see, the mass is here and the string has some tension T and mg is acting downward. Okay, so I'll be discussing about the tension part later. Okay, so you know that the initial velocity is given as u, and after some time, like at this point p, so the velocity becomes v, which is of course less than u because g is acting downward. I have mentioned it here. G is acting downward. So that part also, I hope you understood. Now, my first understanding, like I want to give you one thing, one not approximation, one certain like consideration that I'm taking here. You can see the line which is passing through A, that is called zero potential energy line. So there, that's my imaginary line, and at that line, that is my reference line for energy conservation, or especially for potential energy. I consider that this line is actually zero potential energy line, and anything above the line will have a certain potential energy. Okay, so this at this point, what will be the potential energy? It will be zero. Okay, so that is the that consideration that I'm taking. I hope you understood that part as well. Now, my first goal here is to find out the velocity at that point P. At the given point, I want to find out the velocity equation in terms of u apparently. Okay, in terms of initial velocity. So for that, first I would like to do a small thing. That is, you can consider, look at this, you can consider this triangle. So it makes an angle theta, you can see. So this particular body, when the mass reaches from A to P, when it reaches to P, it angular displacement covered by the string, or the angle covered by the string will be theta. Okay, with the vertical. So now I would be considering the triangle. So from the triangle, you can understand that it covered a height h, then this distance will be r minus h. So I can write cos theta is equal to adjacent side by hypotenuse, which means r minus h upon r. So what will be my cos theta? Again, I can write it as 1 minus h by r, or I can write h by r is equal to 1 minus cos theta, or h is equal to r into 1 minus cos theta. So this you keep in your mind. I want this. I'll be using this later because I want to find out velocity at point P. So like I told you already, the initial velocity at A is equal to u and at P is equal to v. What I'm going to do is, see, I haven't discussed anything about tension. I haven't discussed about mv square by r, that is the centripetal force acting on it. I haven't discussed the components of weight yet because I don't want any of those in order to find out the velocity. So let's talk about the velocity at point P. For that, I am using energy conservation, specifically mechanical energy conservation. So let's apply energy conservation. Let's apply energy conservation at point A and at any random point, that is P, which is given in the diagram, in the figure, as you can see. So what is the potential energy at A? So I know that the potential energy at A is 0 because the A lies on the 0 potential energy line. So what is the kinetic energy at A? That is equal to half m, initial velocity is u. So half m u square. Then what about the potential energy at B? As you can see, the mass actually, look at this, covered a vertical height of h there. So I can say this is equal to mgh. What will be the kinetic energy at B? Kinetic energy is equal to half mv square. Apparently, we have to find out what? We have to find out V. So I'm just going to equate both of them. Potential energy like plus kinetic energy, that is total energy, total mechanical energy is equal at both the points. So then it will be half mu square is equal to mgh plus half mv square. Now look at this. I'm going to cover like I'm just going to cancel all m's and multiply by 2 throughout the equation. So it will be u square is equal to 2gh plus v square. But I want v, correct? So what I'm going to do is like v square is equal to u square minus 2gh. So what will be my v? V is equal to root over u square minus 2gh. So this is the equation. Maybe like we can just modify this equation in terms of theta as well. We can make this equation in terms of theta because I know that what is h, r into 1 minus cos theta. We have already done this. So then I can say that v is equal to, v also can be written as u square minus 2g into r into 1 minus cos theta. So be very clear about it. So what is the velocity? Velocity has two equations. You can consider either velocity is equal to v is equal to u square minus 2gh under root, or v is equal to under root u square minus 2gr into 1 minus cos theta. So I think it's pretty clear, and we are going to find out the tension, and we are going to find out the remaining parts like the difference in tension and everything in the upcoming videos. I hope you understood the basics, and I hope you understood the velocity, and velocity in two ways, like in terms of h and in terms of like cos theta as well. We found out, and if any doubt is there, you ping me or you just put a comment below. That's it. Okay, thank you everyone. We will meet in the next video.